So to get started, I want to just draw something quick, something simple. I do have a little cheat sheet here. Let me find my packet real quick, which I want to do a part that I haven't done before. So let me see. What do I got here? That's my plasma example. Bevel gear, that's definitely not it. Where's my manual? There it is, seminar book. All right, so here we have a little book. Some of you guys may have seen this before. I use it for a lot of my trainings. But we're going to just draw one of these parts. I know I did this one last time we did plasma, but I don't think I've done this one. So we'll do this real simple part. This training is not about, is not really for CAD. If you want to see more CAD, we have a few CAD videos in the on the BobCAD support website. But I'll just draw this one real quick. Very simple part to make. And we're going to start off by drawing two circles, two arcs on the screen. One that's got a radius of 1 inch, one that's got a radius of 3 inches. We're going to center them right at XYZ 0. So we're going to start by going to Create 2D, and then Arc. We'll go with a radius of 1 inch, and then hit OK. And then we're going to do a radius of 3 inches, and then hit OK. And there is the two outer arcs for, where'd it go? This part right here. So we have the inner there and the outer there. So again, a 1 inch radius and a 3 inch radius. Now, after we have that done, we're just going to go into the rectangle command, and we're going to make two different size rectangles. One that is 3 by 1 1/4, and another one that is 1 by 1. Now, the 3 by 1 1/4 also has 1/8 inch chamfers on it. So remember, while you're creating your rectangle, if all four corners of the rectangle show a chamfer, put them in right then and there. That way you don't have to go back and add the chamfer later on. You could just have it in the model. So that has 1/8 inch chamfers, and the 1 by 1 square that we're going to make has 1/8 inch fillets. So we're just going to go back to BobCAD, and I'm going to go to rectangle. And for the length, we'll say 3. For the width, we'll say 1.25. And then down here, we have our chamfer. So I'll say chamfer length and 0.125. And there we have it. Now we'll hit OK. And then we're going to go make 1 by 1. But this time, we're going to use radius corners. So we'll say 0.125. So very simple part. You guys may have seen this part many times before. But we'll kind of get into a couple other things with this for specifically laser, plasma, and Waterjet. Now what I can do is I'm just going to take the center of this square and I'm going to put it right at the 3 o'clock position. So I'm just going to click it and put it right there. Now you have multiple ways of creating the other 3 cuts. I'm going to do the simplest way because I'm already inside the feature for rectangle. So I'm just going to use the snap points to snap another one at 12 o'clock, another one at 9 o'clock, and another one at 6 o'clock. But you could have just used the original and done a rotate, and that's how I do it a lot of times when I'm teaching people how to use the rotate command. From here, we then would use quick trim to trim away all the geometry normally. That's normally what I'd be using, but there's a feature that's overlooked a lot of times. It's not I call it a luxury feature. It's not needed, but it is helpful. And so this feature is called 2D Boolean under the Create 2D. And it allows us to do adds and subtractions of wireframe geometry. So for the inside pocket there, if we look at our drawing, I have no lines through here. So I want to get rid of all the intersecting lines that are inside this inside pocket that we have. Now, when we do the 2D Boolean, we have add, subtract, and intersect. For anytime you're trying to basically clear out the inside pieces of geometry, you're usually going to be adding two shapes together. And that's what we'll see. That's what we're about to do. We're going to add the arc and the rectangle together. Again, this is a luxury feature. All the things I'm about to do, I could also do with just a quick trim. I could just go in and trim out all the entities just by clicking on it, but it's a lot more clicks. So I'm going to go up to 2D Boolean, and it starts off on add. So I'm going to go pick my arc, And then after I pick my first piece of geometry, in this case, the arc, I'm then going to go to the second geometry group. I'm going to hold shift on my keyboard so that I can do a chain select, and I'm going to pick the outside rectangle. So hold shift, pick it. And then if you actually zoom in on the feature and you look at it, my preview color currently is orange, but you can see that the outer border all the way around stays orange, and then the inner lines here are the selection color. They're red. And so what that's showing you is anything that's orange is going to stay, and anything that's red is going to disappear. So when I hit OK, it automatically trims that out. Again, you could just use quick trim for that as well. The 2D Boolean feature it's a great feature. Doesn't work for every situation, and that's why I usually would say use quick trim anyway, just because it is good for just about every situation. And the other side of this is going to be the subtract function. Now, add, it doesn't matter if I pick the arc first or the rectangle. It doesn't matter which order I pick those in. I picked the arc, then the rectangle, but I could reverse that and it'd be just fine. With the subtract function, you have to pick it in the correct order. And it's the same as if you ever do a 3D Boolean as well for a solid model. Basically, you want to pick what you want to keep and then pick what you want to remove from that. All right. So for me, I want to keep this arc and I want to remove all 4 squares from the arc. So I'm just holding shift and picking all 4 of these squares. I don't have to hold shift when I pick the arc, by the way, because it's a single entity. If it was broken into multiple pieces, though, I definitely would have to hold shift and pick it. But just remember, holding shift and clicking on a chain of, a group of entities, a chain of entities, we'll do a chain select and grab all of them. So now what we have is, again, the preview showing what's going to stay, and it's all these little cutouts around here. So we can hit OK. It automatically trims it. Again, nothing different than if I had just used quick trim, but it is a little bit faster if I wasn't talking the whole time. So now what we need to do is just add some fillets onto the corners. The corners are 90 thousandths. So we're just going to go to fillet and then chains because I want to do all the sharp corners. And then right here for the radius, I'll just say 90. And what chains is going to do is it's specifically looking for sharp corners that don't have a radius in them. The thing with this is it's even going to radius, even corners that already have a chamfer on them. So if I was to hold shift and pick this, you'll see we do add a little radius to that corner. Not a bad idea if you're trying to get the most accurate look to your part, because, well, especially for like a mill can never cut a perfectly sharp corner. Neither can most of the things we're doing. Everything's going to be leave some sort of radius. It just depends on the diameter of our plasma or our water jet or whatever. So it will put it on any sharp corner. So in our case, we're just going to hold shift and pick this. And the only sharp corners we have are these ones right here. Since these ones have a fillet in it already, it doesn't try and add another fillet or change the fillet. It's just going to do it to the sharp mates on the corners. So I'll just go ahead and hit OK, cancel out, and there is my little radius there. So there is the part. All right, so now we're ready to start machining. Now, one thing that's been a constant issue, especially depending on your machine, is where do you set your parts up when you're going to cut this? Now, if your machine homes out in, say, the XY, bottom XY corner. So say this is our home position. Depending on your machine, you may draw up in this quadrant right here. You may draw in this quadrant here. It just depends on where your machine homes out from and where the negative Y values and negative X values versus positive Ys. Basically, if you set your machine in the corner of the table and you jog the machine in a positive direction, if it can go positive, it would be based on these two coordinates. The direction those arrows are pointing in are your positive directions. Now, the way that I define, or the way that I kind of think about this is if I'm working on a machine, I actually just finished a training a little while ago, and the guy has just a 2x2 router. So we'll keep it simple. We'll go 24x24. This is the same as any of you guys that have a 4x8, 5x10, whatever size table you have. basically I could go in here and say it's 24 by 24. And right now, BobCAD's going to center that rectangle on XYZ0 because my base point is XYZ0. And I said, go put the center on there. But really, when I do this, what I like to do is choose one of these 4 corner buttons, and that will be kind of my origin. So again, you need to know where that origin needs to be placed on the machine. And then I could go ahead and pick, I'm going to say it's all up in the upper right-hand quadrant. So I'll say use the bottom left-hand corner and put it at XYZ0. And I'll hit OK and cancel out. And what we see now is kind of a visual representation of that part or of that material sitting on the machine. So basically, if all my code is based off of this point right here, and I have a sheet of material on the machine, I can move this part anywhere inside that rectangle where it fits. And it'll give me the proper results, or it should give me a good cut. So before I go and do any tool pathing, I need to move this part. But I also want to talk about some of you guys' machines don't have a work offset. Your machine might use a G92 in the beginning of the code. The G92 is the home position from where the head is currently sitting at the machine. So if your machine uses a G92, what you're going to do is you're just going to go put the plasma or Waterjet near the area you want to start. And then when you hit start, it takes that location that it starts in as your 0, 0, and all your code's based off of that. So let me just grab this part real quick. And I'm just going to go home and copy. And then I'll open a new window. And I'm just going to paste it down right there in the middle of the part. Now, right now, we're visualizing an entire table that we're going to be working with. But say I didn't have a full table worth of material. I just had one piece of material out on the machine. Well, what I could do is I could actually use the center of my geometry as my origin for the job. And basically, if I'm using a G92 and I have a piece of material that's on the table that is large enough to cut the entire part, so in our case, we'd need at least 6 inches by 6 inches. What I can do is I can find the center of that piece of stock, and when I hit go with that G92, it'll use the center, and it'll just cut the part based on from this point outward. So you're not relying on it trying to go from a corner of the machine to your part. You're defining the center of your part and then picking anywhere on that sheet where the part will fit. And when you hit go, it'll work right around that part. So there's a few ways to do it, and it really depends on how your machine does it. If you do have work offsets or kind of known home positions or known positions, then I would always go the route of drawing out the piece of material I'm cutting from and then setting that corner of the material or wherever my origin is at XYZ0 here. So now what I'm going to do is I'm just going to take this part and move it into my sheet here. So I'll go up to utilities and then translate. Now I know the size of my part and I know exactly where I'm sitting. I also like to give my sheet some margins. I like to have area around my sheet where the plasma doesn't kind of exit the sheet because then I have to re-pierce and I don't want to do all that. So right here, I'm going to go ahead and translate this. Let me pick the geometry first. So that's my geometry. Whoop, there we go. And then I'll say, let's move over in X 3 inches. And what we'll see is this is going to line up the left side of that large arc right along the y-axis line right there. So we're going to go a little bit more. I'll go 3.5 inches over, and that'll give me now a 1/2 inch gap between the edge of the material and the part. I'm saying I have 1/2 inch margins. Now, since this is a round part, we could also shift up in Y the same amount, 3.5, and it'll put it right there. When we're done, we can hit OK and then cancel out. So now visually, we can see that I'm cutting one of these parts on that sheet. And what we're going to do in a few minutes is we're actually going to cut a bunch of these. We're going to do a pattern of these parts. So just to do one machining job for now, I'm just going to go over to my CAM tree. And right here where it says CAM defaults, to start a new job, we're going to right click and go to new job. Now inside of here, we have our milling job type. And a lot of you guys might have just the milling. You don't have lathe or mill turn or wire EDM. So it's going to be the only option you have. Now, if you're using BobCAD for only your laser, your plasma, or your Waterjet, I would recommend getting your machine saved as a default so that you don't have to change it. For some of you guys, though, I know that you have both mills, lathes, as well as a plasma. I've worked with some of you guys in doing some online training before. So you might have a different default machine that pops up. We just need to make sure that BobCAD knows that we're using a laser, a plasma, or a Waterjet. And usually when you get a post created by the post department, they will give you a machine and the post processor. So it's something that should pop up. And when you install a post from the posting guys, it'll also set the default for that machine. So you won't have to come back and change that. For me, though, I'm just going to go ahead and use a generic. I'll use this BC3X laser here. But again, if you're using a Waterjet or a plasma, the steps are the same. It's really, these three really go together and they work the same way. So I'll go with the laser because I usually do a plasma. So we'll change it up. And from here, just like every other job you'll do in BobCAD, you have to define the stock that you're cutting from, which for us, we actually drew out. We drew this 24 by 24 square. All we really have to define is the Z thickness. This is just for the simulation, though. So be aware of that. If you don't set the thickness of the material correctly, the only thing that's not going to work right is when you watch the simulation, it won't cut all the way through the part. But I do recommend at least, setting it to something realistic. I'll say we're just cutting this from a little 1/4-inch piece here. And what you'll see is that stock is now a 1/4 inch. Before it was 1 inch. Much thicker. Bring it to a 1/4 inch, and you see it will update to the correct size. So there's our 1/4 inch thick material. And then when we hit the next arrow here, or the forward button, the origin pops up right there at the top of my part at that XYZ0 location. And that's the whole reason we put our rectangle, our stock on the screen, was so that we can, one, see where our coordinates going to be based off of in that bottom left-hand corner. And also so I don't have to actually pick anything. I don't have to change anything. So now I can go ahead and hit OK. And there is my job setup. So the whole job is set up. Again, for now, we'll just cut one, but then we'll turn it into a few more. So there is my part. I'm then going to right-click on Machine Setup 1. And go down to the Mill 2 axis. Now inside of here, when we say select geometry, we're just going to pick all the geometry we want to run right there. Always look at your chains. We have one pocket on the inside and one profile on the outside, or it's all profiles really, but we should have that many chains. There's 2 chains currently showing. The other thing we can do at this point right now is set up the start points for these. This is where the leads are going to happen. So I'll start the leads for the outer cut right on the middle of this line here, or let's do it closer to our origin. We'll do it right there. And then the center pocket, I'm going to pick the straight line here. Now, one thing to pay attention to is the direction that you're cutting in. And if this was a mill and we were climb milling, I would need to reverse the direction of both of these features, because for a climb mill, I need to compensate to the left. And to the left of both of these features puts us on the inside here and the outside here, so it's reversed. But with laser, plasma, Waterjet, you don't have a rotational force like you do with an end mill. So we don't actually have to worry about whether we cut to the left or cut to the right usually. So you could actually set it up left or right. If you want to compensate to the left and cut, it switches. The outside would be going clockwise. The inside would be going counterclockwise. If you wanted to do it that way, then all you have to do is reverse your direction. So now to the left will put us on the inside, and to the left will put us on the outside for the outside. But I'm going to do it the wrong way, or so we're saying. All I need to change is the compensation side. Normally the default is left. We're going to change it to right. That way, when I save this toolpath and I go to use it again, all I have to do is reload that toolpath, pick the geometry, and when we pick the geometry for the first time, we set the direction as if we were going to the right. So this just saves us a step of not having to go back and change anything afterwards. So the 1/2 inch depth is fine. I mean, I have a 1/4 inch, but a 1/2 inch is fine because you're cutting through the part. You're going all the way through with this. And so when we're done, we can hit OK and then hit next. Right here for the feature page, top of features at 0, total depth is at just a 1/2 inch. So nothing to really change there. I'm fine with the depth, so next again. For the machining strategy, there's only one toolpath you're going to use, and it's a profile finish. So you click on Profile Rough and hit this red X here, and you're left with just your profile finish. From there, you just hit Next, and you have tabs. Now, I'm going to do a little example of how I would do tabs on a part like this. I do not use this tab function. I actually just draw my tabs, and I'll show you real easy how I do it. And so we'll go ahead and hit Next for now. Right here, we have our posting tab. So really the only thing you need to pay attention to here is if your machine uses a work offset, you need to make sure this matches the work offset value you plan on using. So if it's a G54, then work offset number 1 would be the G54. 2 would be G55. 3 would be G56, and so on. Next, again, we finally get to define the laser that we're using. So we set up the diameter. This might be something you don't know off the top of your head. You might have to do some testing or contact whoever makes the nozzles for your machine and just find out what they would recommend for the diameter. You might be able to look in the manual as well and see if there's anything listed out. But you'll see right there for the diameter. Right now it's set to, we'll say 10 thousandths. I'm going to leave it there. This is a laser, but like your Waterjet or your plasma is probably going to be a little bit bigger than this. This is one of the smaller options that you can get with the diameter. Now, at the beginning of this, I was talking about the 2 different ways that you'll set up a toolpath here in BobCAD. And the 2 ways are really either you're going to be setting up all your feeds and speeds, and in this case, you could set up your cutter, your gas, and your shutter. You're going to set it up either in BobCAD or not. Right now, if I don't add any feeds and speeds or anything to this, when I go to compute my code, I'm essentially just giving it the path to follow, and then at the machine, I can set up the cutting conditions. If you're lucky enough to have a machine like that, it makes BobCAD a lot easier because really you make one tool path and it doesn't really matter the thickness of the material. You just give it the path to follow. And then at the machine, you define the thickness, the pierce, all that stuff. But if you do have to enter this information here into BobCAD, again, you could choose your cutter options on and off, your gas on or off, and then your shutter open or closed. Now, for the feeds and speeds with a laser and a plasma, plasma has the same options. Waterjet might have something different. But all we're setting up for this, if we are doing it in BobCAD, is the feed rate we'd want to use. And specifically the feed rate we'd want to use when cutting 1/4 inch material. This feed rate might change when we do 1/2 inch material. So that's where if we do have to enter feeds and speeds, what you'll eventually end up doing is saving your tool paths as you create them. So if I save a tool path for a piece of material that's a 1/4 inch, the next time I load it up would be when I have another 1/4 inch thick piece of material. And it would have all these settings in there automatically because you saved your feature with those settings in it. So saving features is probably the biggest time saver you'll have when you're doing laser, plasma, Waterjet. For now, though, I'm just going to go ahead and hit Next. And I'll assume that when we post the code, we don't have all the feeds and speeds in there normally. So this will all be done at the machine, or we'll look. I mean, really just depends on the machine you're running. So next, for the patterns. Now, when we do our patterns, because I didn't change the direction of cut, I ended up resetting the direction of cut. If I go with a left side compensation, I'm going to be on the wrong side of my geometry. So I want to go with a right side compensation. And this is beneficial to you guys using a laser, a plasma, or a water jet, because a lot of times when you pick the geometry the first time, the initial time you pick it, it does come out backwards. By using, or it comes out backwards for a climb mill. It's basically setting everything up for a conventional mill. And so we don't have to worry about climb or conventional. We just need to make sure that the compensation is set to the correct direction based on what we chose, or based on the geometry. So next we then have our parameters. This is a finish pass, and specifically we use finish passes because they're made for finishing. Move my microphone. Give me 1 second. I got to take a drink. By the way, I didn't mention it at the beginning. I kind of did. But if you guys have any questions that pop up throughout this, feel free to throw them in the questions box. Ask whatever you need. And if it doesn't pertain to this right now, I will try and get to it later on, just so you know. So you could ask questions if you're stuck on something else with laser, plasma, water jet. Let me know. Yeah. So for the parameters page, the side allowance, when we choose a finish pass, it's already set to 0. That's the big reason why I pick finish passes instead of rough passes, because with a rough pass, I have to remember to come back in and I got to make sure I change this stuff is all it is. Depth-wise, doesn't matter. That's all going to be handled when we set up our cutting conditions. So next again. Right here for the leads. Now, with your laser, really with any of them, we need to account for the amount of kind of blowout we're going to have when we pierce through the material. I would prefer not to do that right on the edge of my part. So we could choose a bunch of different lead types, but if you're saving a tool path, which is what we're going to try and do, what I would recommend is try and find the leads that work for most situations. A right angle lead is a great choice. For a lot of situations. It's probably one of my favorite ones to use. A circular lead's not bad, but you got to think a circular lead ends up, a right angle lead is just a line. A circular lead ends up being a bigger thing. So if you're working in a small area, I've done a lot of stuff with plasma, and for cutting logos and stuff where there's real small geometry, sometimes your lead can be the problem causer. It's the one that's causing everything. So a lot of times circular and blend could end up being a little bit too big. And I don't want it to pierce here and then feed in. I'd rather it just pierce and move straight to the wall. So right angle for me is my kind of default value for this. I don't like to use parallel unless it's on the outside of a part like what this picture shows. The problem is that parallel lead really only works on the outside cuts like this. Right angle works on all of them. It works pretty well on most cuts. So I'm going to go with a right angle lead, and then you'd have to factor in, the material you're blasting through. That's going to change your kerf. If you're normally doing, a 1/4 inch, that might take, less than a second to pierce through. Where if you're going to 1 inch or 2 inch material for like a plasma, it might take a few seconds to blast all the way through it. So the pierce should blast through it, but basically I want to make sure that I give it enough of a length that even if I overburn my initial pierce, I don't touch the geometry. I'm using a laser right now. I got the laser diameter set to 10 thousandths. So I'll leave it at a 1/4 inch and just try it like that. Now, one other thing you can do just in case is when you lead in, you can cut around the part, and then either lead in or lead out in the exact same spot you let in from, or right here we could do an overlap amount. And the overlap amount allows us to just say, I want to go past where I let in from by, we'll just say 100 thousandths, and then have our lead out happen. Perfect. We'll go next. Right here for the corner types, I'm not changing anything on that page. Just going to hit next again. As far as machine sequencing goes, I always use optimized. BobCAD is smart enough to recognize inside versus outside shapes. So it knows that it needs to go cut the pocket of this geometry before it cuts the outside profile. So we shouldn't have to worry about it. The sorting's pretty good. And really, it's two pieces, but it's one internal and one external. So there really is no wrong sorting for this. And finally, we then have our advanced feed rates. So we can convert our rapids to feeds, which shouldn't be anything you need to really take care of here. Your lead in, lead out feed, none of this really matters. Down here, though, is the corner slowdown. Now, you got to think, as you do, I'm just going to hit finish on here. As you go and make a cut, and I'll try and figure out how I can show this. A lot of people picture the cut that you make a little bit differently than what it really is. And for those of you that have used your plasmas, a hand plasma, you kind of know what it's like. The stream of plasma is not going straight down. As it's moving, it's actually got a curve. It kind of goes backwards. So what ends up happening is when you get into a corner, basically we want the plasma to catch back up with itself. We want the end of the plasma that's blasting through the material to straighten itself back out. So what this corner slowdown option allows us to do is say, when I get close to a corner, so I can do it for all the corners, I can tell it within a quarter inch of a corner, I want to slow down to a 50% feed rate. And what that's going to do is, as we encounter that corner, it'll slow everything down, kind of let the plasma catch up to itself, and then make the turn so we don't accidentally blow off a corner or just have a really bad finish in the corner. This corner slowdown is specifically made for mostly plasma, but you could use it for your laser as well as your water jet. But I'm not going to run anything like that right now. When we can't hit next anymore, we're just going to hit compute. Now, this is a really small tool path, so I'm going to go ahead and blank out my stock right here, and then I'll zoom in, and there is my tool path. It's only 10,000, so I'm only offset by 5,000 right now, and there's our one part. So I'm just going to go ahead and say save as, and let me put this on, I'll just do desktop, or actually, yeah, desktop, repeat training. Did I not make a folder? All right, so let me go ahead and make a folder real quick. And I'll call it Laser Plasma Waterjet Files. And say open. And then we'll do, this is the laser example. All right, there we go. All right, so we now have it saved. So I always make sure to save whenever I'm doing a, right before I launch the simulation. Anytime I launch the simulation, I save. I've had a heck of a day today working on a real simple little part, but it's a little test we're doing for the techs and everyone around here. For some reason, it's a simple little part. I'm not even going to open it. There it is in the image there. But it's been, every time I've closed my simulation today, there's something it doesn't like about that part. So hopefully it's corrected itself. I restarted my computer earlier to give it a nice fresh load. So we're going to go right here to start simulation. And we'll just wait for it to load up. Now your laser and your plasma, and we're going to do a plasma example because it's a little bigger. They show up as red in here, and your water jet will show up as blue. But essentially what it looks like is it's almost like there's an end mill, in this case, a real tiny end mill. And that's just the view of it. But it's just, that's how it sets it up, just so we can see everything. So I'll set my speed a little slow on this. It shouldn't take too long to run. And then just say run. And we'll see. There's our first lead in. And we should be coming through the whole part, so we should see the same thing on the other side. And there's our lead in and around over the end, and then leads out. And we should have the same thing here when we do that. We'll overlap that and then come out. At that point, it's kind of, it doesn't matter. That part's free when as soon as it closes the cut anyway. But there we go. It's just going to cut its way around. And right there. So there we have it. Now to see that individual part, there's a feature in here that some of you guys might have clicked on accident before because it's really annoying when you don't know what it is. Under the measure tab here, normally when you're working in the simulation, you want to leave this guy on off. And the reason being, when you rotate inside the simulation, you left click and hold and move your mouse to rotate. But the way you do a shortcut rotate inside of the CAD window where we drew this part is by clicking the middle mouse wheel like a button and moving your cursor. The problem is I always come into here and use my middle mouse wheel as my rotate command because I always forget that it's a left click inside the simulation. So if the measure entity or the measure box is turned on to something, it will actually do those things as you click on them. So I'm putting down points on that surface. What I really want to do is down here we have the remove chips options. So there's remove chips, select chips, which allows me to go in and pick what I want to get rid of. So if I click this middle section with my middle mouse wheel, it'll trim away the inside. If I click the outer piece, it'll trim away the outside because it's no longer connected to that material. And so now I can see what my part should come out looking like and overall the finish and everything. So let me restart this simulation. I'm just going to fast forward through. Another option is remove chips, only keep one part. And so instead of picking the parts I want to get rid of, I can so I'm using my middle mouse wheel like a button and click on the object I want to keep. And we'll just wait for it to clear out everything else around that and show us our final result. Another way of doing this, and I don't recommend running it this way, especially with a sheet this large, but there is an option called remove chips by volume. And this one allows you to remove chips that are smaller than a certain size and also remove any chips that happen during the simulation. So as the simulation's running, and I say run, as it finishes a cut, it should automatically disappear. So right here, as it finishes this part, the inside should automatically disappear. Now, we might run into some problems with this one because the larger piece of stock might be around it. Normally, I would use this on a bunch of parts that have, where the sheet isn't the biggest area, I guess. But there it is, same cut. And there we go. So nothing fell out. I just have to do my remove chips. Nothing's seen as small enough because I didn't really do this. So I'd have to say remove chips with a volume smaller than, I don't know, 1. And so I'll say refresh. That didn't do anything. We'll say 2. I don't know what kind of measurement this thing uses. There it is. So whatever the volume is smaller than 2 of, I don't know what units, but you'll see it automatically got rid of that piece. And if I went bigger and bigger and bigger, eventually this piece would disappear and leave just the stock around there. So just be aware that that is a thing. When you're done using this remove chips button, though, make sure to turn it back off. Because if you accidentally come in here and click with your middle mouse wheel, it'll get rid of a lot of material. And clicking with the middle mouse wheel, even in the middle of a feature, will actually trim away that geometry as well. So just be aware of it. It's the differences in how we rotate between the CAD window and the simulation. So I do it all the time and accidentally trim geometry out that I didn't mean to. But there it is. So what was I talking about with saving toolpaths earlier? Well, after we have this toolpath done, and in my case, the way I set it up right now is I said that the feeds and speeds don't matter. I'm setting up all the cutting conditions out at the machine. So at this point, I could actually save this toolpath. So I'm just going to right-click on the Feature 2 axis and say Save Feature. And then this is going to be my laser profile. And then just say Save. Now, after I have that saved, all right, and this is the best part, I'll pretend I'm starting a whole new job. And so there's no toolpath on here. Well, now what I can do is I've got my geometry in the right location. I've got the stock drawn out. And so when I go and do this, it's going to be the same steps. I'm going to go create my stock wizard. This time I'll do the laser again because I got that saved. And then I'll load my stock wizard. I'll create a piece of stock. I'll set my thickness. And again, because I don't have feeds and speeds and I'm going to do all my cutting conditions out at the machine, I could now set this to whatever I want. For the toolpath that I saved, the depth is set to 1/2 inch. So if I want to simulate properly, I would want to make this, smaller than 1/2 inch, or go and resave that toolpath and have it go, 2 inches deep. The depth that we set inside the feature is irrelevant with all these machines because you're riding around on the top of it and blasting through. So it really doesn't matter. But I'll go with the 1/2 inch thickness and then hit next. And then right here, our origin is in the same spot, and then hit OK. Now from here, I can just right click on Machine Setup 1, go down to Load Feature, and I'm going to choose my laser profile and hit Open. It'll ask if I want to use the same top and depth values. Absolutely. The top for every one of these jobs should be 0. And then the depth is kind of irrelevant. But again, to make it simulate properly, you need to make sure your depth is at least thicker than your stock or the same size. In my case, it's a 1/2 inch. We should get a result. After you load a toolpath, it's the same as copy and paste. So copy and paste, save and load. Whenever you copy a toolpath or you load a toolpath that's been saved, the geometry is the only thing that we forget about. So if I right click on the word geometry here and say reselect, let me go to a top view, I can pick all my geometry once again. And then over here under profile chains, I would then go in and make sure to pick my start points. And again, I'm not reversing the direction of this because right now my toolpath is saved with a right-sided compensation. So whoops, sorry, I punched the microphone there. So for this one, to the right puts us on the outside, and for this one, to the right puts us on the inside. I explained it to someone last week, and he liked it a lot. That's how he kept thinking about it. But the way I've always pictured how I know if I'm supposed to go to the left or the right is I picture myself walking down the line. Left side, in this case, puts us on the inside. Right side puts us on the outside. It's a real easy thing to picture because even some guys get confused when the arrow's pointing a different way. If that's the case, move it to the other side. And now you'll see, okay, to the right puts us inside, to the left puts us outside. We always want to set up our geometry for however we set up the toolpath. And for me, that was with a right side compensation. So all I got to do is hit OK, compute that toolpath, and there it is. We're done. All right. When it comes to posting, how do we post? We just say post up at the top. You got to make sure you have the correct post processor first, but I'll just say post, and there is all of my code. Now, another thing we can do is make an array of parts. So I want to fit a few of these in here, get a whole sheet of these things. And we need to just know kind of how many are going to fit. And the way I do this is with the translate function. So first, let me blank out my stock here, and I'll blank out my toolpath. Now, you do not have to move the geometry. That's one of the biggest things here. You don't actually have to make copies of the geometry. I'm going to, and then I'll hide them to show you. But I do like to make copies of them first, just so I know how many I can fit. So I'll go up to the Utilities tab, and then I'm going to use the translate function. Just like before, I know where I'm sitting, and I just need to make sure I give a gap large enough to fit, parts between this. So I'm just going to go ahead and pick that part. And then in my y-axis, we're not going to move for now. We're just going to set up enough that I can fit 2 of these next to each other. So it should be about 6. And that would be, for this laser, that's actually probably close enough because the laser's only 10 thousandths wide. But for now, just to set it up the same way, I'll go 6 1/4. So 6.25. Just like that. From there, I can then say how many copies fit. Well, I think 3 is the only value. I think we can only fit 3. So you'll see if I add 3 copies, it gives us 4 because we take the original and then add the number of copies. And so you'll see we're sticking out past the edge of the part right there. So I'd have to go with 2. Now, I'm wasting a bit of sheet, but we could adjust things and kind of move things around later on. But I'll go ahead and hit OK. And then from there, I'm just going to drag a box over all 3 of those parts. And I'm going to offset them upward. So we're going to zero out the X and put a 6.25 for the Y. And now I have 9. And I can't fit another part there. Definitely not, because it's the same width as before. Yeah, okay. So we'll go 2 copies and then just hit OK. So now I'd be cutting 9 of these parts out. And this isn't the most efficient way of cutting these arcs. Really what I'd want to do is probably go to my translate feature again and pick all of these middle shapes. Let's see if I can get this right down the middle. We could pick all 3 of these, and then I would shift them over. So I'll say about 3 inches, because that's the diameter. And that would center us up in the middle, and then we could tighten that in and actually move these down a little bit. I still have copies turned on, turn those off. So that would, the orange that we see there would be the new positions of these 3. Still only going to fit 3 parts, though. We might be able to move these close enough. Really, it's my margins that are probably throwing us off. And, well, actually, it's the fact that we're using a 24 by 24 piece of stock right now. I got a 6-inch diameter part, so the most I could ever fit would be 4 parts across, but that'd be with no gap between them. So not something I'm going to do. So 9 parts is what we'll get. So if I wanted to do all 9 parts right now, I could go in, let me remove the old geometry. I'll reselect the new, and I'm just going to drag a box over all 9 of these parts. Now, the problem is I now have to figure out, where's a good start point for all of these, and I have to set up the start point for every single one. So just picking it. Another thing you could do is right here, we could say, use the start of a chain, use the start of the longest entity, or in my case, I could say, let's use the middle of the longest entity. And you'll see that actually set all of my coordinates for all the outside shapes into the corner I actually wanted. That's a fine place to be. But on the middle, I might not want to start on a curve, on a radius. So for the middle, I'll come in and pick all of these right here. So I just got to click all these, grab that one there, and then that there, and finally there. Now when I hit OK and I recompute my toolpath, we'll see all of our toolpaths for all 9 parts. So not a bad way of doing it. It works. Takes a little bit more work because you have to pick all the geometry, repick all the start points and everything. So another way of doing this is, let me go ahead and remove the old geometry there, and I'll just compute to get rid of all the toolpath. And I'm just going to hit undo and bring myself back to 1 part. I now know my distances, which is helpful. I know that I want to move over 6 1/4 and up 6 1/4. And I know that I need 2 copies. So what I'm going to do now is I'm going to pick a single one of these. So I'm just going to pick this guy here. And then now I only have to define my start points for the 2 pieces I want, like the 2 start points that I have. Hit OK, and then I can go and compute that toolpath, and there's my cut. From here, I can right-click on the Feature to Axis, and in here we have an option called Add Toolpath Pattern. Now, a toolpath pattern just copies the toolpath, and then we define whether we're going to do an array like we want to. We could do a translate, so we could say I want to cut one of these here in this corner and one in the other corner. I don't know. You could rotate, which not for us for this point. And then we do have points. So points is a good one if you have a bunch of, if you want to put parts out in kind of random places, I'll say. Not really random, but in other locations. You're going to pick a point to define where you're moving from on your model. And then you're going to pick the other points that you want to make a copy at. But for us, we're going to go with the array command and hit next. And we'll say in the X distance, we're going to go 6.25. And we have 2 copies total because 3 doesn't fit. And then in the Y, we're going to go 6.25. And again, 2 copies total. And when I'm all done, I can hit OK. And there is the array. Same exact toolpath as what we would have gotten if we left all the parts on the screen, as you can see by me undoing that. You can see they all line up perfectly. The difference is just I only had to set up and work with one single part. So now I could hit save, just again, because I'm going to save before I go into the simulation. Start the simulation and wait for it to load. And then now when I say run, and I'll leave it kind of slow for now, we'll see it's going to run the inside shape and then the outside shape. And then it's going to move to the next one, just like that. Now, one thing you may also have to think about is, well, heat for, your plasma and everything. Heat might be a problem. So using a toolpath pattern might not be the best option if you're trying to, spread the heat across the entire sheet. Maybe you'll cut this part, then this part, then this part, then this part, and kind of work your way around there. Or maybe this one, then this one, then this one, then those ones. It's all up to you how you end up cutting those. If you want to do it where you're spreading that heat around the part more evenly, the best way to do it is to use the translate feature and make all your copies. So you'd have all your geometry out here, and then you would actually pick them. So let me delete this, and then I'll remove my geometry. And so I'll say I want to start on the middle one first, and I'll do the middle and the outside. And then I want to go to this one out here, middle, outside. And then this one here, let's go all the way over here. We'll go middle and outside. And then middle, outside. Come on, grab it. Oh, am I frozen? Hold on one second. It's been acting up all day. Don't know what's going on. All right, come on, you can figure it out. Let me open up my task manager. All right, I'm just going to shut it down and try it again. But basically what I'm doing is I'm going and picking them in the exact order that I want them to cut. Give it a second. I have my task manager up here. Oh, there it goes. BobCAD wasn't loading. So I'm just going to end the task and start it over real quick. Open that up. Give it a second to load up. Sorry, guys. It happens. And today it's been especially slow. Every time it happened earlier actually when I was picking some start points for some stuff. So that's why we save often. Pretty much if you're always saving before you get into the simulation, then a lot of times it should work. So, you'll have a fresh copy of it. So try this thing again. Gonna pick it, pick it, pick it, pick it, pick it, pick it. No, I'm getting some bugginess when I'm selecting geometry. All right, good. This is a good one. We got this recorded too. Perfect. Yeah, it's frozen again. I don't know what's going on with that. But normally when you do this, and I'll report this to the development team and see what the heck's going on. Normally when you do this, though, it will it'll let you pick them in whatever order you want. And so that's super helpful for if you're trying to spread that heat. Now, there's one trick to that, and I'll show you here in a second. It's the sorting that you do on it. So I'm just waiting on BobCAD to reload now. There we go. And come on. There we go. All right, so I'll reopen my part right there. And so I'm not going to try and pick the geometry again. I don't know what's going on. It's for whatever reason, whenever I pick the inside shape on one of those. But normally, if you did pick all the geometry, when you get down to the machine sequence tab, now currently I have it set to optimized. So optimize is usually, the way that optimize actually works is it's using one of the other sort orders. It's using either closest, no sorting, X direction, or Y direction. It's basically finding the most efficient one out of all of those, but it doesn't take into account the like thermal, it doesn't take into account any of that stuff. So optimize is a good choice if you're just doing one part, because it's just going to kind of sort it inside to out. But right here, this no sorting option, a lot of people get thrown off with this. What no sorting is actually doing is going in the order that you pick the geometry at. So when I say no sorting, if I dragged a box over my part, it will seem very random, because when you drag a box over geometry, you're not picking it in any specific order. You're not picking it from the upper, left-hand corner down to the bottom right, if that's the way you dragged it. When you release the mouse, it grabs all the geometry all at once. So you got to make sure that, well, one, you have good geometry, because if you got bad geometry, you're picking duplicates if you're dragging a window. And two, you got to make sure it's efficient enough. Usually, if you're dragging a box over your geometry, no sorting is not going to be the option for you. But if you're going in and manually holding shift and picking all your geometry like I was a second ago, then no sorting is the best option, because it's going to go in the exact order you picked them in. All right. So I'll try and hit compute on here. Actually, I just have the array anyway, so it doesn't really matter. But yeah, normally when you pick your geometry in the right order, or the order you want to go in, the no sorting option will put it there. All right. So there is a kind of quick run through of it. Now, what I want to do is I'm just going to copy one of these and the outside border right there, and I'm just going to copy that, and I'll cancel out and open up a new window. Now, I just want to show how I do tabs, just because I like control over where the tabs go. The way I do the tabs is basically just by breaking the geometry. And so I can actually go in, I'm going to create a rectangle that is, let's say 0.5 by 0.5 or 0.25, whatever. And then I'm going to go and put it right here on this edge, and I'm going to center it right on that point. Now, I don't want my tab to go this way, so I also want to rotate my rectangle by 45 degrees. And that'll be my little tab. So I'll hit OK. Now, instead of going and placing this one down and doing all four of them, what I'm going to do is just go to Utilities, Rotate. I'm going to hold Shift and pick that little square I just made. And then for the rotation center point, I need to make sure to move this to the middle point here, so that when I do my rotation, it's rotating around the correct center point, or the correct hub. And then I have four of them I want. So 360 divided by 4 gives us 90 degrees between each part. And that's a nice even spacing. And then I'll go with copies. And I need 4 total. And I have drawn 1. So remember, your copies are always your total minus what you've drawn. So 4 minus 1, it's 3. I don't know why I hit 4. And there it is. So now we'll see a copy there, there, and there. And we're going to keep our original. So we'll hit OK and cancel out. So now what I have is these squares that run over the part. I'm just going to start by going in and trimming out all the insides of the square, like so. From there, I'm going to cancel out, grab my select tool, and I'm just going to hold Shift and pick all 4 of those little squares again. And then delete them. So I'm left with just these broken chains here all the way around. So this area is going to stay connected to my sheet of material. And I'm still going to have leads on it. We're actually going to load in the same toolpath. So right-click, New Job. We're going to do our stock wizard. We'll go Next. Right here, we will... hold on, I picked a milling machine. I'll have to switch it to my laser in a second. Stock there, I'll set my Z depth to 0.5. And then once again, we'll use that bottom left-hand corner. So I'll hit OK. And I forgot to switch my machine here. So I'm just going to right-click, Edit, choose my laser, and then hit OK. So now when I go into my feature, I can right-click, go down to Load Feature, and I will pick that same laser profile I made earlier. I'll use the same top and depth, so I'll use that. and I'll right click on the word geometry and say reselect. Now from here, I'm just going to hold shift and pick all 4 chains. Now when we're picking a single chain that doesn't connect to something else, but it does have multiple entities in it, you can still chain select. You just need to make sure to hold shift and pick the end of a line. We don't want to pick it at the beginning or the middle of a line like here, because it's only going to chain that section. So we always want to go to the beginning of a line, hold shift and click, and it'll send the chain along the entire length of the line. So I'm just holding shift and picking all 4 of those and the inside shape. And then we'll look at our chain. Well, hold on, let me do this. Let me pick the inside shape first, just in case it sees these as not an outside shape. And then I'll just pick all 4 of those. And then we can go and look at it. So again, think of it, to the right of this one will put us on the outside. And to the right of all of these, as we can see, they're all pointing the same direction. To the right of all of those, we'll put them on the inside. So this one's wrong and those are wrong, which is good news. That's actually how we want it to be. If something's going to be wrong, we want them both to be wrong so that we can go in and just reverse the direction of all of them. And then I'll hit OK. And with this toolpath, I already have the right angle leads on it. The only thing I'm going to do is edit my feature, go to the leads tab, and I'm just going to turn off the overlap amount. So I'll delete that and then say compute. Whoops, I forgot to put a 0. There we go. So put that a 0 back in there and then compute. And so if we blank out our stock and we zoom in, there's our cuts right there. So it's there, cutting around, going around. And so this will ensure that the machine stops it'll actually shut the plasma or the laser or water jet off and then move. In the past, I know that the tabs button that's inside of the 2-axis feature, depending on how your post was set up, it would fail to turn off the cutting command. So it would have a tab in it, but it wouldn't shut off the plasma or the laser. So it would just end up cutting through the tab anyway. But here we go. We'll say run. And you'll see there is our part. So this would fall away, and then we'd have to come in and cut those off. But we do have something holding that part to the rest of the stock. You know, especially if you're doing a big sheet of a lot of parts, the last thing we want to do is have a part come loose, tilt up, and then get smacked into by the plasma head or the laser head or whatever. So there it is. There's some quick, easy tabs. And if you're doing sign making or you're doing logos and stuff, get used to that. You will have to add tabs in pretty often. I think I can use this one. Let me see. Where did I put that? Part files, Mike. Come on. You could search. See if I got this old part file on here. Or if it's on my old laptop. I don't know if I have it on here. Give me a second. All right, so here's a little example of a part that I made back in 2018. So I'm a Cubs fan, unfortunately, and so I didn't want to do a standard Cubs logo, so I decided I wanted to do this Harry Carey logo because he's the announcer I grew up listening to, and so if you look at this whole thing, originally the glasses connected over to here, and this line didn't exist. It was just kind of a line that came down for the crease of his nose, and so this continued on right there. The problem that I was running into is if I make that cut all the way on the outside, all the way through here, I also have a tab for the nose there, and it would continue all the way around. Well, there's no definition for the glasses. The full glasses would end up falling out. I lose all the definition for the nose. So I had to come in and put some little tabs on here where they made sense. And I figured that's a pretty decent spot. You don't really notice them on the sign. Same thing for the lips. I came in and I added these little tabs in here. I just drew some lines and disconnected them so that when I put my profile on it, it cuts inside of that geometry. And that's something you'll have to do whenever you're doing logos. If you're using BobArt to do stuff like this, that's a big thing you'll have to worry about because things fall out. Sometimes you get lucky. Some logos work just fine. Actually, the Minnesota Vikings logo, I'm also a Minnesota Vikings fan, didn't take any work. I was able to just use BobArt, or actually I didn't even use BobArt. I just found a DXF of it online and was able to cut that, and everything that fell out was supposed to fall out, and it actually came out with a really good finish, or a really good overall clean thing. I have it somewhere here. Yeah, I got it right there. So this one, when we go and cut it, you say run. There it is. Cut the whole thing. And what I'll do now is turn on the measure function. And this is where I like to go to remove chips, only keep one part. And I click on the area I want to keep. And everything that falls away is what would fall away at the machine. And so there is the sign, little Harry Carey logo. So there it is. Quick and simple, and you get an idea right from the simulation. You'll know when you get it wrong, because in the simulation, if you go to clean up the parts and something falls away, there was probably something that didn't get cut right, or some tab that didn't get created and it fell out. Like I said, the Vikings logo, though, if I open this guy up, there's the tool path for it. I didn't have to do anything. I was able to just come in. I didn't have to add any tabs to this. Every bit of geometry on here that's supposed to fall out is its own separate piece of geometry. So something like this, if I say start simulation, I could say run. We'll do, this is on a plasma as well, not a laser, right here. It's doing all these cuts. These are all still internal cuts that I got going. I might have some leads that are a little bit too big, like you can see right there. Has a little chop out of it from the lead in right there. But let me close down this thing. Quit. There we go. And there it is. So now I'd go use that remove chips, only keep one part. I'd go find where I want to save. So I'll go to right here and click on it with my middle mouse wheel. And with this many pieces, it might take a little bit longer to process, but that is the cut. So I'll go to a top view, and that's what it looks like. So it's a lot of it comes down to finding good geometry or good parts. There's a lot of websites out there if you're doing, some sign making, logo stuff. There's a lot of websites that when you search for files online, you can find some good ones. So you could go in, I'm just loading up a new browser here. All right, move this over, new window. So I could go into Google and say, I'll just do the same one. So Minnesota Vikings logo. And then whenever I'm looking for stuff, I know a lot of you guys might have BobArt, and it's a very cool feature. That all takes having the right kind of pictures and stuff like that. Whenever I search something online and I think someone may have made it before, or I might find something, always follow your search up first with DXF. For those of you that don't have BobArt, this will save you a lot of time, because there's a chance that there's a lot of places to find DXF files. I actually did some work with a guy that was in one of my training classes just randomly. He worked for Ball Corporation, the people that make mason jars. And so he was trying to do some logo work with that. And originally all we had was the logo. So Ball Corp right there, logo. So originally we went in here, found the images, and then went and actually did some BobArt on it. But by going in and adding that DXF afterwards, we were actually able to find some vector files, and right down here is the Ball Corporation logo as a DXF file. So someone had already made it and it's clean, and I didn't have to do anything for it. I was just able to download it and run it. If there's one recommendation I could give you guys, if you're going to be doing stuff like this, use Google Chrome or use Mozilla Firefox. Either one of those will work fine. I think they have it for the Microsoft Edge as well. I just don't use Edge for anything. And not only use those ones, but go download a program. If you go into your add-ons for your browser, there's extensions that you can add to them. And there's this extension right here. It's called uBlock Origin. It is a free ad blocker. This website, when that's not enabled, is messy, and there's multiple download buttons because they got a bunch of stuff linked into there. Do that when you're searching for your DXFs, just because a lot of these websites that I've been on, not to say that they're sketchy, but their ads, the ads that people pay for on the sites there's a lot of them. I don't even know if I can I disable this? Element, more. See, I don't know how to, is there a way to do it? Click to disable cosmetic filtering on the site. No. There's a way to see it, but I forgot how to turn this off. Basically, this thing blocks all the ads for me, so I don't have to see it. Also blocks them for YouTube, so little perk. It's called uBlock Origin. And again, I would use that anytime I'm searching for some of these, because some of these sites are just covered in ads. It's hard to find them. Now, if you have BobArt, you also have the ability to download Adobe Illustrator files, AI files, and PDFs. Those are specifically called vector files. So if you're doing your search, you could go, let's go back to the Minnesota Vikings here. I could go follow this up with vector, and right down here you'll find an EPS version. There's JPEGs or stuff like that. An EPS, an AI, or a PDF are drawn with lines. So they're all done already. You don't have to mess with anything with them, other than potential cleanup. You might have to clean up some geometry, which can be tedious, but for the most part, an EPS file or an Adobe Illustrator file, those go right into BobArt and they open up real easy. A lot easier than going through the entire process of BobArt, especially if your logo that you find isn't black and white. Like this one right here, that's a decent one. If I was using BobArt all day, we could run that one. But this one here, if we were to go and try and make that one, it looks like someone drew it by hand. I don't even know what's going on here. Just a sloppy one, but it's also got colors in it. And colors do throw off BobArt quite a bit. There is a color mode for it, but it could be a little bit difficult to make things work. So that's just some tips on searching the internet and kind of finding anything you're looking for logo-wise or whatever you're looking for. Follow it up with DXF, and there's a good chance you'll find someone has done the work for you. It works out pretty nice. So there we go. All right, so we've talked about tabs and whether or not you need them. In some situations, you will have to go in and add your own tabs. Just depends on what you're making. Depends on what you're cutting. So there we have it. Any questions from anyone so far? If you got anything, make sure to throw it in the questions box and give me 1 second. Now, I've been doing all of this using the laser. I just want to note once again, the steps for a plasma or a Waterjet are the exact same. So I'm going to delete the toolpath I have on here now. And I'm just going to change the machine from a laser. We'll go to a Waterjet and hit OK. So again, the way I've done it as of now is that's assuming that all the feeds and speeds and everything you have to set up for the machine to run is handled by the machine. Some of your guys' plasmas don't handle it that way. So you might need to come in. When I say plasma, I mean all three, just by the way. Some of your machines might not do it that way, where you have to enter the feed rates here at BobCAD. And so when we do that, you'd go to your mill 2 axis. We'll go pick our geometry. I'm just going to pick the two of them once again. And we'll go right here and right here. And then we could go ahead and hit OK. Now, depth-wise, this one I would want to remember. You know, we're setting this up as if it's cutting a 1/2-inch piece of material. So right here, we'll hit Next. Next again, we have our machining strategy. And then I'll choose my profile finish. And then just next my way through till I get to where I define the water jet. So I define the water jet. And then right here, if, again, we're setting the feeds and speeds here in BobCAD, we would set up our feed rate. So we'll say, 50 inches a minute, whatever. And then the pierce dwell. How long do we pierce for? And this is going to be specifically for 1/2-inch thick material. So I'll say pierce for 1 second. Pressure type, you got high, medium, or low, as well as your cutter on or off, your abrasive on and off, and your vacuum assist. Other than that, it's the rest of the settings are the exact same as what we just did for the laser. So I'm going to go with a right angle. 1/4 inch is fine, probably more than we need. Let's say 0.1. Next again, corner types, no changes. Sequencing, I'm only doing the one part right now, so I'll leave it right there. And then our advanced feeds. Excuse me. So when we're all done, we can hit compute. And I didn't reverse the direct. Oh, I must have clicked that one. So let me just right click and say modify. And I'm just going to flip the direction of that arrow there. Put that on the inside. This one's good. I didn't have to change it. I must have double clicked on the arrow. You can flip the direction of the arrow just by clicking on it. And so sometimes when I move it, I accidentally click a second time and flip the direction of it. So there we go. Hit OK. And then we go and compute that. So now when I post my code, this will have my feed rates in it all throughout the program. There will be feed rates actually running in here. And so for me to save this toolpath with those feed rates, I would right click. I'd say save feature. And for this one, it would be Waterjet. Waterjet. And then you don't want to put decimals. All right. The fastest way for your computer to corrupt a file and kind of ruin the file is by having an extension that it doesn't know. So a lot of people will come in here and they'll say 0.5, thick. The dot that you put in your file name designates the file extension. That's why you have a .bbcd or a .dxf. So the problem with this is it sees this file extension as .5 space thick. So you have to come up with your own little code there. Just spell it out. 1/2 inch thick. Let's capitalize that T there at least. And then I'll say save. So that now is going to be saved for any job I use 1/2 inch material on. I could then change that toolpath. I'll edit this, go to my Waterjet and say, okay, if I'm cutting a 1/4 inch piece of material, I want to go 80 inches a minute, and I only need a 1/2 second dwell. And then I can compute that, right click, save feature, and then right here, we'll just change the 1/2 to quarter. Whoops, I had caps lock on before. So 1/4 inch thick, and then save. So I'd save a copy, or I'd save a toolpath for every different thickness of material that I'd have, because it's going to save the feeds and speeds. It's going to save my pierce dwells. If you're working with a plasma, it's going to save your pulse frequency and all that stuff. It's all saved in there, so it's one less thing that I have to worry about. Now, the only thing I really have to worry about when I'm setting up jobs for this 1/4 inch or 1/2 inch thick part is the leads themselves. What's the thickness of the material, and where am I working? If I go and put a lead, just like we saw with this Vikings one here, Where is it? There's that one little spot. Where was it? Right there. So in this area where it gets real tight, it's actually starting. If you look, the start point for that, it doesn't show it because it's such a small area. The start point for that guy is actually happening right where that lead is. It's here, but it's the length of it is actually way over here. So that's a problem. That's why we had that little overburn there. This one really depends on the thickness. And then because it's a broken shape, what I might actually do is close off this piece of geometry right here and then treat this as its own individual shape and try and get my start point actually lined up right here so that as I lead in, it'll cut down and move. Or the little stuff might have to be a little thing. But that's the only thing I'd have to worry about after I get this all set up. I'd be able to go in and just have it, all I'd have to worry about is making sure my lengths for my lead ins and lead outs are good. And after that's done, post code, ready to go. All right. So let me go ahead and blank this out. Oh, I just got to click off that. Now, is there anything specifically you guys have been struggling with or anything that's been hanging you up when you're working with your plasma? Is there anything that's been throwing you off? All right. Well, if there's not, we'll continue on. There's really not too much to the laser plasma water jet. The most important thing I would say is when you're, making this stuff, you just got to pay attention and use your simulation. Make sure to trim out that geometry in the simulation so you see what falls out, and that'll give you a really good idea of what it, what it needs. So, all right, is there any way to pierce only hole centers for drilling and reaming later? Other than drawing real tiny arcs, I don't know. Let's try it. Let's do it. I feel like there isn't a way other than drawing real tiny arcs. But let's try doing a, how would it do this? This is the Waterjet. All right, so let's use this. We'll remove this, and we'll try it with a point first. All right, we'll put a point right here in the middle. I don't believe that a point will do anything because it's not an option for geometry picking. You always know what geometry is available for any feature. Any feature in BobCAD, you can find out what geometry you're allowed to pick by looking at this toolbar right here. So I could actually turn it on and pick that point, but there's no chain or anything. So I would say you would want to draw... I feel like there is a way to do it, and I'm just blanking on it right now. I'll find out for sure, but the way I would probably do it is with a real small arc. I would look at the Waterjet. I got a 50 thou arc on here. So I'm going to start with a 50 thou diameter arc. So I'll say right here, let's go 0.05, and I'll just snap it on top of that point right there. And so if we go and run this now, I know I've done this before. There we have it, our chain. We want to go to the right, so we'll flip it to the other side. Hit OK, and we'll just hit compute. And so 50 thou, or the exact same size of the part of your diameter of your tool is a little bit too small. Let's go ahead and make it. Let's go here, arc. I'll say, so we went 50 thou before. We'll go right there. Let's go 60 thou. So we'll go 10 thou over our other arc. And let's try that guy. Geometry remove, geometry reselect, pick the arc, direction, flip it, and compute that guy. And I got to turn off edit this, turn off my leads, and that little guy could work. And we might be able to go even smaller than that, and it'll just make kind of a little arc, but really... not that I know of. I feel like there is a way, and I'm blanking on it, though. I could definitely let you know if there's a way to pierce just the whole centers, because you're going to go drill them out later on. Oh, I have a way of doing it. I remember now. So one way of doing it, and this might sound weird, is engraving. All right. So in engrave, let me just make, I'll put down a point. All right. So I'll put down a point. I can't engrave a point, but I can engrave a tiny little entity. So from that point, I just want to move over, we'll just say in X, 0.001. So we'll say 1,000. Let me just try that. And then that's there. So now I have these 2 points. I'm just going to go connect a tiny little line between them. It's, what did I say, 1,000? Get out of here, you. To there. And then I'm just going to delete the 2 points. Just like that. So I have that little entity on there. Where the heck did it go? Right over here somewhere. There it is. So there's my tiny little line. And so when I go and set up my job now, let me just copy that toolpath and paste it. All right. So here's the thing. When I go and do this one, I could pick this piece of geometry. I don't really care about the chain direction because when I go to compute this, it might give me a toolpath, as you can see, but that toolpath is offset by whatever the radius of my definition for my tool is. But it's only offset right now because on the patterns page, I have system compensation on. So we can turn system compensation off and treat it like an engraving toolpath. So it's going to turn on. In this case, it's going to move over 1,000. No, yeah, 1,000 and then shut off. So it's kind of as long as it needs to take that, but you also could set up your pierce on there. And so it basically pierce, the move that it makes would be tiny, and then it would shut off. And that could work for blasting a hole through something. I think that's how I've done it in the past with some customers that we're going to end up opening up, drilling the holes or reaming them later on. Just draw a tiny little line segment. Like I said, my line just now was 1,000. And that's enough to give me a cut. And so if I cancel out of this, do I still have the outside one? No, let's get this one. Let's remove the old, reselect. We'll pick this and this. We'll set our start points there and there. To the right. And to the right. To the right. No, that's wrong, isn't it? The middle one's backwards. Reverse that. There we go. So to the right puts us inside. Don't know why it's picking the geometry backwards now, but compute that. Whoops, compute that one. And there's our cut. I don't have any leads on this one. I turned them off just to for the last one. But I now have this little guy in here as well. So we can go ahead and save. And we'll just start the simulation. And then we'll say, let's run this thing. That little hole is going to be real quick, so I don't want to go too fast. Center pocket. And now, because I did this in the order I did, it's going to do the inside and the outside and then come back and do that little pierce. I should have put the pierce above this one so that it runs in the right order. But now we'll see it should go in. Make its cut. And then there's our little pierced out hole that we had. So again, just draw a tiny little line. That seems to work pretty good. And then make sure you set your pierce time accordingly. And with that tiny line, it shouldn't even, let's go to a top view and, let me hide the tool. Hold on, visibility, tool, hide. From that small of an entity, you can't really even tell that it's an oblong hole. But again, it's, try that way. As far as I know, there's no way to, you can't drill a hole with a plasma. Or can you? Mill drill hole, select geometry. I'm going to pick that point in the middle there. Hit OK. Diameter, that shouldn't matter. Yeah, so that's, okay, so that's the problem. We have no way of picking the plasma if we do drilling, right? Yeah, we have no way of picking the plasma as our tool. So drilling wouldn't work. I thought maybe we could do a drill and just do a on pierce, but that doesn't work. So yeah, draw a little line. That should be the easiest way to do it. And I mean, I'll talk to some of the guys. I feel like there's another way for it, but off the top of my head, I can't remember. So, any other questions? Anything else you guys are running into? All right, I'll give you a minute. It looks like I think someone's typing right now. Hold on. All right, that was a good question. Thanks, guys. All right, so really that's it. I mean, it really comes down to those are the basics. It's tough to talk about laser plasma water jet for a super long time. The biggest thing is going to be what problems you guys run into as you're running your parts. So, you know, if you do run into any problems, most of the time with how simple these tool paths are, a lot of the times the problems end up being caused from the main two things is the origin being in an odd spot or the post processor's got something wrong. So that should always be your first. I mean, that should be your first step anyway. Go through and set up your machine, get your post done, work with the posting department, get that all worked out so that when you're ready to actually run this stuff, it's good to go. Most of these posts are fairly simple. Even this Waterjet post that I got right here has more stuff in it than some of them. If I go use the Bailey Waterjet here, and normally, this is a very simple bit of code. You have your on-off commands, and then you got all your settings. And this is even more complicated than some of their plasma post uses a G92. So this one uses... there's your pierce delay, custom beginning. There's your pierce. That's all your abrasive stuff. So this one uses like a G92 as well, as opposed to some of your guys' machines might use a G54. I'm not sure. It all depends. So, any other questions I could answer for you guys today? Like I said, laser plasma water jet's about as easy as it comes. It's just figuring out whatever you guys might be stuck on. If it's CAD, that's a different story. There's a lot to the CAD that you got to know how to do. But yeah. So, what about modeling custom lead-ins? Absolutely. So I usually do custom lead-ins on a situation like this one here, where I'm using tabs or doing something like that. Let me blank out all the toolpath here. So something like this, custom leads are very easy to use. The thing about custom leads is you're usually doing it as sort of an engraving toolpath. So the first thing I would want to do, this is my laser, and I got it set up to, let's say it's at 10,000. I'm just going to scale this up and make it 100,000 just so we could see more of kind of what's going on. The problem is right now I have it doing a compensated cut. So it offsets automatically. All right. Has perfect hole or diameter pro, not sure, but it spirals in for holes with overburn, but no default options to do that. So he's saying Hypertherm has perfect hole or diameter pro. No, we don't really have anything like that. I mean, we do. I just never tried it. Let's put down an arc. Let's say its diameter is just a 1/2 inch for now. And we'll slap that bad boy right there. Now, in theory, and I'm not sure about this theory, but in theory, instead of using a profile finish, I could go in and use a different 2-axis toolpath. So let me go ahead and pick this. And I don't need to worry about the direction now. The reason being, instead of using a profile finish, I can go and use a pocketing strategy. Now, again, I've never tried this before, so this would be something you'd have to let me know how it goes, but it should potentially work. So I'll set it up with a pocket. And I'll next till I get to my laser tool. So there's my tool right there. There's the diameter. And so I'll say next. And so I could actually go in and say, I want to use a spiral for circular pockets. So if it's if it's a nice hole, I could do a spiral for circular pockets. And then you could do a step over amount. I would equate this, the way I think of this working would be the same way as a wire EDM. So wire EDM, the normal way of cutting apart is you cut the outside, just like you guys do with a laser, a plasma, or a water jet. You cut the outside and the slug falls out. But there is another option called a coreless cut, which is used to size up holes without dropping a slug. Basically, turn the entire pocket into chips is what we're doing. And so we have our spiral. It knows the size of the laser, and we have a step over that we could set up. I'll leave it on 50%, and we'll see what we get. But this use spiral for circular pockets should be able to do it. For the parameters, we just need to make sure our side allowance goes to 0 because we're not running a finish pass after this. For the leads, just going to plunge in with a single depth. We don't want to change that. And then the sequencing would be for multiple pieces. Links, shouldn't have to worry about that because we're doing that spiral. And then we have our advanced feed rates. So we'll hit compute, and there it is. Now, like I said, I've never done this before. But in theory, it should work out just fine. You're basically piercing through the center of the hole. I believe because we have it set up with the laser, we could set up a pierce time on there as well, or any of them. You set up your pierce. Let's see what it looks like in the simulation. All right, so I'll leave this one pretty slow. So I'll slow that down. And 50% should be good, but we might go down to 45% or something like that. We'll find out. We'll see what it looks like. So it's going to pierce in. Oh, I got my tool turned off. Hold on, pause. Tool, show. There we go. And run. Oh, it's taking forever, eh? There we go. So it's going to pierce in. And then spiral out from there. Just like that coreless cut. Now that doesn't take into account any overburn, but your pierce is going to pierce, and then it's going to be dependent on the size hole more than anything. I think if it's too small of a hole to even take care of the overburn, there's nothing we could do about it. It's going to burn through regardless. So on bigger holes, yeah, you should be able to do that with a pocket. Good question. I haven't used a pocket on this before, so that's a good one. But yeah, it's a pocket, and then I would only try. I mean, you could use it on whatever you want. You could get even crazier with it. It depends on what package of software you guys have. Some of you guys will only have the Mill Express, which is really all you need for laser, plasma, water jet, because it's got the. I mean, you'll have pocket. What you don't have available to you is the advanced pocket. You have the morph spiral and the adaptive roughing. Now, I wouldn't ever run adaptive roughing with it, but morph spiral could be another one that's pretty good. Essentially, turn the entire pocket into chips. I could see this working as well. So but again, if you guys have the Mill Express and that's all you have, you won't be able to use the morph spiral or the adaptive, but you can, if it's a round part, use the spiral for circular pockets. The difference is a morph spiral can cut really any shape that you give it. It just doesn't have any linking moves between the cuts. Everything kind of leads to the next cut. So yeah, good question. All right, let me close out of the simulation. So modeling custom leads, back to that real quick, does get a little bit more intricate because usually when you're modeling leads, you're not offsetting your tool path. Like right now, we're offsetting this entire tool path. Let me go to a top view here. We're offsetting that entire tool path. But if I was to go model my leads, so maybe I wanted some leads, I'm just going to add some splines to this just to make it kind of wacky here. Maybe I got this goofy lead. I don't know why I do it. Let's go there, hit OK. There's one lead, and then on the lead outside, it's over here. whatever, hit OK. So those would be my custom leads. The problem is it's going to offset from this lead over and then kind of end up here. So what I'd actually do, get rid of those two splines, is I would offset my geometry over. So under Create 2D, we have offset. I think this is the toolpath I changed to 100 thousandths, right? Come on. Yeah, tool diameter I set to 100,000. So I would offset this by 50,000. So distance 0.05. And I'd start by offsetting that geometry outward. All right, and let me hide the toolpath real quick. And then off of that line there, I would add my custom leads. So I'll do my spline. And then I'll add my spline. And there's my two, custom leads. Now, the difference in how I run this would be instead of doing the geometry, like this, and with the offset on it, let me reverse the direction there. That still applies the offset. So the way we fix that is by doing an engrave. And I don't mean go use an engraving feature. I mean, in the feature of the profile, to turn it into an engrave is on the patterns page, we would turn our compensation to off. And that is going to do a center line cut and follow your geometry. And then normally with that, I would get rid of the leads because I still have my right angle leads. I would set a vertical lead in. And then that way it pierces right there. It cuts around and it's done. And I meet some people that when they get their parts from whoever gives them their parts or when they draw their parts, the way that they're actually drawn is by taking into account the laser, the plasma diameter automatically. So they actually have that built into the into the drawing. So they would never use compensation. All their drawings, all their outside pieces of their drawing are made a little bit bigger by whatever the radius of the part your cutter is, and then any of the inside shapes would be smaller by that same amount, so that you're doing that center line cut. Basically, when we do this center line cut, the edge of our tool or the edge of our plasma or whatever ends up running along that and leaving us that edge. So yeah, you could totally add your own leads, but usually when you add your own leads, you're going to be engraving, I'd say, is the most common way of doing that one. So also, good question. Thanks, guys. Any other questions I could answer for you guys today? Anything you've been running into? At this point, doesn't even have to be part of the laser plasma Waterjet. Is there any CAD features you guys have been stuck on? I'm not going to go into 3-axis or anything, but anything you've been stuck on, let me know. All right. Well, that's pretty much what I have to talk about today. I'm going to be here for a few more minutes for about till 3 o'clock. I'll sit here. If you guys have any questions or something pops up in the next 15 minutes or so, let me know and I'll jump back on here and talk to you. Otherwise, next week we have, what's our live event? Next week's 3D. So next week is 3D CAD and CAM. Next Wednesday, 2 hours. I will not be doing it. I'm actually not sure who's doing it. We might actually have to cancel it. I got to look because I'll be out of the office and Andrew will be out of the office traveling. So we just have to, we'll just have to figure it out. But feel free to sign up for it for now. You'll get an email if we do decide to cancel it. So let me know if you guys have any questions. And thanks for coming. Thanks for joining us on this one. And let me know what questions you got if you got anything. Otherwise, have a good one, and we'll see you next time.